Hi. We still have some people trickling in. I just wanted to kind of introduce myself and Chad and kind of let you guys all know that you're in the right place or potentially the wrong place. We are doing a talk today on ES6 and a little bit of stuff from ES7 in the JavaScript language. I want to make sure everybody understands this is a pure JavaScript talk, and it's not specific to the ArcGIS JavaScript API in any way. So we thought we would give you guys, an opportunity to explore stuff a little outside of Esri specific technology in this talk, just as kind of like a mental break from all of the wonderful things that you're learning about in the new versions of the 4.0 API. So with that being said, I encourage anybody who wants to go learn more about Esri product, feel free to kind of move over to one of those sessions. And just in full disclosure, we're not going to be showing any mapping technology or anything of that nature. This is strictly going to be showing off some of the new features that have come out in the latest versions of JavaScript, and just kind of go through an exploration with you guys on that. So as far as introductions, my name is Daniel Lewis, and this is Chad Rutherford. Basically, it's going to look weird. I'm standing down here. He's standing up there. Traditionally, I don't do a really good job of talking and typing at the same time. So I asked Chad to come here and basically be my mouse pointer and my typer. And also he is responsible for coming up with most of the content for this talk and doing the research on it and making sure that we fully understood the ins and outs of the items that we're going to be talking to you today here. So with that being said, we just want to talk about the current state of JavaScript and how it's moving into the future. So we've had JavaScript in the browser for many, many years now, and we've been kind of locked. Well, I speak still currently. For many years, we were locked into a certain set of functionality. They were calling it ES5 for JavaScript. And the reason that we were having trouble moving forward and evolving the language was because of legacy browser support. And, sorry. No, I'm going to, are you hearing me okay? Yeah. And in terms of legacy browser support, the problem being that in order to write the newer parts of the language, you would have to either bring in all of these elegant checks for, hey, if I'm in Internet Explorer 5 or 6, do it this way, and if I'm in 7, do it that way, 8, 9, etc. And then we started to introduce this idea of polyfills, where you could bring something in which would kind of bridge that gap in the older browsers to kind of smooth it out so that you could write consistent code. They don't often think of it, but one of the very first polyfills was jQuery. And I'm sure every single one of you is familiar with that. And what jQuery did was it took the DOM and it gave us a unified language that we could speak to interact with the DOM. Anybody who had to do JavaScript before jQuery came along really appreciated what jQuery did in terms of the selector language and our ability to manipulate and update the DOM. But we're not here to show you jQuery. We're here to show you the features that are in ES6. So let's kind of talk about how you can bring ES6 into the browser today. So there's a project called Babel.js, and it is what's called a transpiler, and it will take your new ES6 and ES7 code, and it will compile it down to older ES5 JavaScript so that it will continue to run in older browsers. And then on top of Babel sits many other compiling engines. Some you may be familiar with. You can use Gulp and Grunt, which are like Node task runners to...
I'll turn it off.
We can use Node task runners to target or to use Babel.js to compile our code down into usable code. There's also systems that have been built to sort of bundle everything. And one of them that's very popular right now is Webpack. And another one that was kind of popular but has been losing ground to Webpack was Browserify, where these tools will do CSS compile as well as JavaScript compile. It'll kind of take care of building your site down to HTML, letting you work in newer languages like Sass, Less, and ES6. So with that being said, I'm going to kind of move to the back of the class so I can see the screen with you guys. And then I'll let you guys focus on the screens as we go through the different areas of the language. So the first thing we're going to be taking a look at is JavaScript introduced a new way of declaring variables. So currently, or historically, we would declare variables in this way, which is var a equals a, or foo equals bar, or something of that nature, right? And var is very powerful, but it has some interesting ways that it reacts when you start dealing with some of the scope changes that you do sometimes in JavaScript. So what Chad's setting up here is we're going to mutate our variables inside of a function. And then we're going to check what happens to the variable that we declared with var. And we're going to take a look at what happens to the variable that we declared using the new syntax of let. What we set up here is we're going to execute this function, and we're going to check what the value of a and b are before the function call and after the function call. And just to kind of like familiarize yourselves with the environment here, we're running Node, so we're not actually transpiling this, and we're running Node 7, which does ES6 support. And then on the right, you see as code. And on the left, we're just running an auto refresh on our Node application to output the console.logs that you're seeing there on the left. So what we've seen here is that this kind of works how you would expect. We go inside of the function, and we redeclare A and B inside the function. So the scope of that function like encloses that variable change. And then when we get to the end, we're actually able to have the A and B from the outer scope continue to be what we expected it to be before we execute the function. But if we change that function from a function to some other type of closure, like an if or a for loop or a while loop, and execute the same code, well, we get an error because our function goes away. But so what you see now is the A, which was changed inside that scope of that if block, actually leaked out into the global space, where the B, which is declared using let, was scoped and held true to the block of context that we were trying to change inside that if statement. So it's a small thing, but it's one of those things that makes a lot of JavaScript very, very hard to manage when you do start dealing with stateful things that transfer from scope to inner scope. And anybody who's had to deal with this and figuring out what this is, it's very much kind of in that same area. So was that the extent of our variable demo?
So now we talk about object literals.
All right, cool. So yeah, so now we want to show like a new way in ES6 to declare objects. So traditionally you would say like let a b equals colon a b b, right? So this is how we've declared objects in JavaScript forever. And when he runs this real quick, you'll see that actually created an object with a property of A and a property of B. But because it's so often that we do things like this, one of the nice things that the ES6 has brought to our capabilities is the ability to remove that colon A and colon B if we're adding the properties that are the same name as the variable that we're putting it on. And then we can also do these compiled properties where we can, using the square bracket notation, write in the object creation syntax to have it create like that. So it's a nice syntax change, allowing us to create objects a little easier on the fly. Obviously, if you want the property to be something other than A or other than B, you would need to explicitly set the name of that property. Cool. So I think that the next thing we want to move on to is another new way of declaring variables. And ES6 introduced constants. So constants is the idea of a variable that I'm going to declare and I'm not going to change. And when we're working with primitive values like strings and booleans and numbers, it actually enforces it quite well. So like you see, what Chad just did right here is he declared the string, and then he tried to overwrite the value of it, and he actually erased an exception, right? And you also can't redeclare it. Once str has been defined, it can't be redefined later. But what gets interesting, and as you guys will start going online and seeing examples of how people are using const in ES6, is it's not actually immutable completely. So when we're going to create a couple constants here of arrays and objects, and then we're going to show that you actually can work with these things and change them. So we've created an array, and let's see if we can put something into that array.
Yeah.
All right, so we obviously we just outputted the contents of the array. Now we're going to push into the array, and then we're going to do array afterwards. So you see, we are actually able to mutate it. But what we couldn't do is we couldn't say ARR equals something else. That's going to throw an exception because that's actually JavaScript saying, I see that you're trying to change a constant, but I think that this is actually a bit of a weird sort of failure of their constant pattern, but you see a lot of people doing this for objects, arrays, and functions, where you basically use the constant to declare the object, and then you know that it's always going to be an object or a function, and you know it's always going to be a function. So it just makes your code a little more trustworthy. I don't think you can push, oh, you're not, you're on the object. Right, so same kind of idea, right? We're able to mutate the object. We couldn't actually redefine the object if we wanted to. All right, so I think that's just pretty much constants in a nutshell. So the next thing I want to show you guys is a new syntax update called arrow functions, which is probably one of the coolest new parts of ES6, because I don't know about you, but anybody who spent any time in JavaScript, you spend a lot of time writing the word function over and over again, right? So Chad's creating just a basic function, and we're just going to call our function, right? That was a little dark with the equal sign there, but basically what he's doing is creating that parentheses on the left is basically the exact same thing as the, we'll put that other one back real quick. So where the function name and then it has argument, right? That arrow function this is essentially the exact same as what we've written above if we wrote arrow function as the name of the function up there and args as arguments. So now you can go ahead and clear out the one on line 3. So this comes really handy when you are doing kind of inline functions, anonymous functions, this type of thing. So what Chad's actually just done here is he wrote a function that receives A and it returns out A plus 1. So I don't know if you want to write out the whole thing so we can compare what the two would look like. Right, so that's essentially the same thing. Where, but because it's only doing one line and it's an immediate return, you're able to kind of remove a lot of the unnecessary syntax out of the language. Now, whether you want to do that or not, it's completely up to you, but it's available to you. You may look at that and say, yeah, it's not immediately obvious to me that line 7 is a function. It looks more like an assignment, and that's a valuable statement. But some people prefer this type of stuff whenever they can get those one-liners. As developers, a lot of times we really kind of get excited about being able to do something that used to take 4 or 5 lines and dropping it down into 1. So I think the next thing we want to show is, I mentioned earlier, scoping this, right? And figuring out like how to access this is always an interesting exercise in JavaScript. So since we're in Node, this is actually just an object. It doesn't have anything on it. But if we were in a browser, this would be window. But what we've done here is we've added a property of this.whoami. And now we're going to go inside of our traditional function, and we're going to try to get access to that this.whoami. I think you just execute it. Oh, yeah, there you go. So what you see is the outer this didn't move into the function, right? Just in unlike the way when we were looking at variables earlier, this doesn't pass in because the function itself has its own sort of concept of this inside of that executing block. Same reason why when we changed the variables inside of the function, it didn't leak into the outer scope. So historically, if you did want to bring this inside of a function, you can use call or you can use bind, and you can pass your scope into it. But it makes for kind of like some ugly code and stuff like that. And then you still have the question of like, which this is this and which that is that. So the arrow functions actually solve this problem by not defining their own scope for this, and they carry in the outer this. So you see he executed this one, and we have I am the top this declared or echoed out 3 times, right? So it's pretty cool, right? The next thing we're going to go on to is destructuring. So destructuring is a new capability in JavaScript to take an object which has some properties on it and to turn that object into an array of variables. So what Chad has done right here is he set up an object with 3 properties on it, A, B, and C. And now we want to pull off the values of that object and assign them to individual variables of A, B, and C. So what he's done on line 9 is how you would have traditionally done it in ES5, which is you just say, hey, here's a variable and equals the object.property. But what we're seeing on line 10 is destructuring. So what destructuring does is says, given the object on the right, I'm going to look at it and I'm going to try to find properties of B and C. And if I find those properties, then I'm just going to go ahead and pull the property off of the object and I'm going to put it onto the variable B and C. So you see it works just kind of like as I described. And it gives us, a good easy way to kind of flatten objects out and destructure them. So I think the next thing we're going to show is arrays. Is that kind of where we're going here? So you can use destructuring in the same way with an array, but it's by index. So obviously an object has property names that you can leverage. The arrays just have an order in which to pull off. So what you see here is he's gone in and pulled out the 0 index and the first index and the second index, right? But 0, 2, and 3 by destructuring that array. I think you have. There we go. Hopefully that makes sense. Like the array one is a little bit of an edge use case that I personally haven't found a use for just yet. But it's, I guess it's kind of nice if you're doing things like passing an array into a function and it's an expected number of items in the array, then you can cast them down to individual values.
And then another thing to note is if you want to skip an index, you kind of have to do this weird floating comma in your assignment.
All right, cool. So now we're going to move on to the spread operator. The spread operator, which is kind of like destructuring, but it's a little different because you're putting it on the arguments array for a function. So we'll just give him a minute here to kind of prep this up. So what we're writing right here is a basic compute volume function that's just going to take in height, length, and width, multiply them together, and echo back the volume of whatever object that we sent in, right? So we'll go ahead and call this. So we're going to set up our dimensions, right? So it's a triangle apparently. Wait, no, what would that be? Height, length, 1, yeah, it's a octagon. No, it's not that many sizes. All right, so now we're going to call our compute volume, and we're going to get back, what, 6?
Yeah.
Right. Okay, but now with the spread operator, we're able to take this action and we're able to clean it up considerably. So the first thing we're gonna do is we're going to take it and we're gonna just spread that that array into the function, right? So very similar to what we were just looking at in destructuring, we're able to just inherently, by adding those 3 periods in front of the array, say that the first item in this array goes on to the first item in the function definition, the second one goes into the second, and the third goes into the third. So he just ran it, right, and we're seeing 8 now. Cool. But you could also use this syntax on when creating functions, right? Oh, wait. Remind me, what are we doing here?
So this is doing the same thing, but with objects.
All right, cool. Oh, right. So now, as opposed to passing an array into the function, you'll see what we've done right here is a lot of times when you create functions, if you're going to have more than 1 or 2 parameters in it, people will just take in like a params object or something like that, and then inside of the function, you'll want to then take that params and do some sort of default valuing for the items that you receive into the function, and then process the activity inside the function. So, but with this new syntax that you're seeing on line 9, where we've created a function that takes in an object with height, width, and length, we're predefining that signature of what we're expecting that function to receive. And then we can just call the print volume by handing in an object with those properties. And the important thing to note here is that in his example here, he's put length as the first item of the object that you're passing in, and length as the last item in the signature of the function. So it works exactly the way you would expect an object to work, and passes it in. So this is a nice little handy way to write your functions and have it a lot more declarative in what the object that you're supposed to be passing them into is supposed to look like. Was that pretty much everything on the spread, or did we have something else?
Yeah, now it's classes.
All right, cool. So now we're talking about classes. And when we moved into ES6, classes was actually one of the most requested features of the new language, because so many people are coming from object-oriented programming languages like Java or C#, and they want to feel comfortable in JavaScript. And one of the things about JavaScript's prototypical nature was that, while it sort of works like a class structure, it doesn't really work like a class structure, and traditional developers have trouble transitioning from the object-related world to the prototypical world of JavaScript. So what we're seeing here on the screen right now is we've created a class, and we're calling that class shape. Think of it as like an abstract base class. And it has a constructor, and that constructor takes in a set of properties, and the properties here, we're expecting the prop to have color. So we could have done the exact same thing that we just did in the previous example, where instead of doing props, we could have the spread operator kind of saying : color. It'd be a little more specific there. Right?
Like that,
yeah. You rename it to color. But basically, like, the idea is that this constructor works as you expect a constructor on a class to work. Whenever the class is newed up, it expects you to pass in some properties, and then it's going to use whatever the properties are that's passed into it in that constructor, and it's going to create the thing. But let's go ahead and scroll up. There's some more interesting things that are happening on this class definition. So the next one I want to bring your attention to is what's happening on line 9 and line 14. So this is a property. We can access this by going to shape.color, which I think we are actually doing right there on line 28. So you see that you're not accessing it through a function call, but what you have up above is a getter-setter pattern, where we can actually inject code that will execute whenever the property is either asked for or is assigned. So what you see there on line 10 is we're firing a print call to the color, right? And then we're also, whenever we set it, we're printing out that we're setting the color as well. So right now you see that it echoed out that it's getting the color because we asked for it. If we uncomment out line 29, we'll actually see as well that when we execute this code, that we have setting color executing in place right there. So this is a great place for data validation. And when you're creating your classes now, it's not just like regular objects where you have to go in after the fact and interrogate the object and make sure that the properties are the type of value that you're expecting and in the value ranges that you expect them to be. Moving down here, though, what would classes be without inheritance, right? Or are we moving to inherit? We just wanted to execute.
Well, the other thing is you can also set getters without being able to reassign it.
Oh, sure, of course. So yeah, so on line 19, we see that get. Go ahead and move back to the code. On line 19, we see that we have a get area, but we don't have a set area, so that's a read-only property that's being exposed. So you can go ahead and say shape.area equals something, like you did there on 32, but it doesn't do anything. It rejects it, and it just keeps the read-only the functionality that you expect from it only being a getter, so you can protect properties on your objects. No more just randomly naming things with 2 or 3 underscores to let the people interrogating your API know that they shouldn't be fiddling with those values. So cool. So now we're going to talk about inheritance, right? So on line 35, you see that we're creating an instance, or we're creating a subclass of shape that's going to extend the superclass of shape onto rectangle. So we've asked for new properties on our constructor, right? We're asking for a width and a height because we need that in order to make our rectangle work. And then, oh yeah, we go back to the left, perfect. And then we've only added a new function to rectangle of get area. But in true inheritance fashion, this is still going to have a color. So you'll see that down on the line that he's highlighted on line 47, we're passing it a height, width, and a color. So all the functionality that we had in the base class continues to work, but then we're able to also have our area computed for us because we were able to add that additional area property. And then in the same kind of vein, we've added circle here, just to kind of show, that we can do other things. And also we wanted to show you that we actually know how to write pi r squared. They're on line 59, which is JavaScript doesn't really support like the caret operator to 2 powers, so it's just math.pal, this.radius. And the other interesting thing here is that we added a static variable to the class. If you scroll up a little bit.
It's right here.
Oh, it is. Oh, I didn't see the word static because it's kind of dark. Yeah, so then the static pi right there. So that's the, like if you're, go ahead and just print that out. You can show kind of how you access that. So yeah, so the very bottom on line 74. So what you'll notice there, what's significant about that is that's capital circle. That's the class itself. That's not the instantiated line 68 lowercase circle because it's static. Right, so when you have static properties, the static properties or functions attach to the class itself, and not to the instantiated versions of the class. So this is kind of like some object-oriented programming languages do it this way. Others, I want to say .NET would actually, if it was a static, it would work on the instantiated version as well. Cool. I think that's everything we wanted to talk about on classes. So now we're going to move to something that, when we were first looking at it, we didn't really get it until we spent a little bit of time in classes, and then we started to understand it a little better. And this is proxies. So a proxy is it's like a pseudo class for objects. So the idea of a proxy is that I'm going to have a base object, but then I'm going to wrap this proxy around it, and this proxy is going to sit and watch the object. Yeah, don't uncomment that yet. That's a ton of stuff. Oh, you're just deleting it. Perfect. So the proxy is going to, in a sense, watch the object for any changes, and when any changes happen to the object, then it's going to perform some code. So if any of you have worked in Angular or some other frameworks that give you the concept of being able to watch changes to a variable and then do things when those variables are changed, this is now that implemented natively in JavaScript itself. But you have to kind of do it in a certain way to get that functionality. You can't just do it on a traditional object. So let's show you kind of how that looks. So on line 3, 4, and 5, you'll see that we're just creating an object with a property of name. And then we've also defined a handler function there on line 6. And well, it's not a function. It's a handler is an object, and it has a getter and setter property. And this getter and setter is going to fire whenever any of the properties on target are changed. So what you receive is you receive the target, which is the property that's being changed, or the target object, right? And then the key is the value that they're trying to change, right? And then the setter, very much in the same way, receives the target object that's being changed, the key, and the new value that we're trying to stick on it. So now, if you're writing an API, what you would do is you wouldn't expose target out of your API. You would expose the proxy item that we've declared on line 16, which would then give you the ability to have listeners that run whenever the properties are changed. So what Chad just executed right there is you'll see that when we ask for proxy.name on line 18, it tells us, hey, I'm getting that property, right? And then just like we saw in the class example just a second ago, when we also, or the setter goes first, sorry, and then when we ask for it on line 19 and we ask for it on line 20, this actually works better if you comment out line 20 first and then execute it. So you'll see that the getter doesn't actually execute right there because we went back to the target object and asked for its name. So we printed out 1, 2, 3, 4 proxy, but we didn't actually execute that line 8 where we're printing that we're actually getting it. So if we comment out line 19 and just uncomment line 20 and now execute this.
That's it. There's the getter.
Oh, did it say it up there?
Yeah.
Okay, yeah. So you see that the getter activity actually what's happening on line 8 fired because now we're inside the proxy and the proxy has that watch syntax that's on it. So I think that was was there anything else you think is worth talking about on proxies here?
I think a real key point for this is you get that validation thing again. So in this instance, we're trying to set the name to be a number, and so we do a quick check in our setter saying, is it going to be a string? If it is, then we go ahead and set it. If it's not, then we kind of yell and say, hey, has to be a string. And the time that this will be really useful is if you are creating your own API and you want to expose and you want to have some sort of validation method of what can be what. As you know, JavaScript is very lenient and you can do whatever you want. This will kind of limit the user to only be able to set strings to strings, numbers to numbers.
Cool. All right. So with that, we're going to move to promises. So for those of you who have not yet discovered the power of promises, I will say that it's one of the most powerful parts of like asynchronous programming in JavaScript. So the idea of a promise is that I'm going to do something, and when I'm done, I want something else to be happening, right? So usually that's an AJAX call from the browser. So we've kind of brought in a library for Node called Needle, which is essentially going to make an HTTP call to that URL on line 3. And before we do this, can you just bring that URL up in the browser so people know what that looks like? Because it's going to be ugly if we pay no attention to the Star Wars guys.
Oops.
Chad, by the way, is an insane Star Wars geek. So afterwards, any of you guys, if you're into Star Wars, track him down and he will talk to you all afternoon about, can you blow that up a little bit? About all the things that are happening in the Star Wars universe these days. So this endpoint, all it's doing is just returning a collection of like 10 Flickr images. So it has a URL to the Flickr image, the thumbnail, name of the photography, and what category that we've categorized this thing into. So just kind of like going forward, this is going to be somewhat important to understanding the rest of this demo. So over here, we're going to make a function here for Needle to just go to the URL that we hand it, and it's going to echo out what it received. So you're getting an error.
No, that's the response.
Oh yeah, you're getting a response. Well, it looks like an error, right? Well, because Needle is giving us everything, right?
Yeah.
So I want to say if you do stuff.body, then you'll see just that thing that we just looked at in the image. Yeah, it's just not great because it's kind of circled around on itself. But anyways, so this is an asynchronous thing. So if you like, we can do a console.log down here on line 10, or the print or whatever, right?
And then what do you want to print?
I don't know, just say something, right? Just to show that this actually executes before we get the callback from Needle, right? So this is Ajax 101. JavaScript keeps going down the stack, and then when it gets that response back on line 6, then it jumps back into the execution chain, and right. So then we see, something happens first. So what we're going to do now is we're going to convert this into a promise, and show how you can start leveraging promises to do some kind of interesting things when you have a lot of these calls to make. As Chad sets this up, basically I'm going to lay out what we're about to write, which is what we want to do is we want to make that first call, then we want to iterate over that collection, and we want to download the binary bits of all of those images. So if you think about what we're going to do is we're going to get 10 things down, and then we're going to have to loop through each one of those the URLs that we receive for the image, and then we don't want to finish executing until we've downloaded all of those images, and then we're going to go do the next thing. So
Oops.
I want to say that function should just be called get, right? Because we're not necessarily getting images.
Yeah, that's true.
All right. So first kind of things to notice here on line 8 is that this function is returning a new promise, and that promise receives an arrow function, right, that has two properties that get passed into it: resolve and reject. And then inside of that needle call where we had the print command earlier, you'll see that instead of printing on line 11, he calls the resolve to complete the promise. There's also the ability in here on line 10, if we were to get some sort of error, to reject it, and then the promise has a very well-defined pattern of, if an error happens, to go ahead and echo out that error, which he's going to demonstrate right here by mutating the URL on line 15. And just do it on line 15. Let's do it like a plus and like ABC or something like that. Right. So basically what you see here is because we have two execution paths, and the promise is a well-defined pattern that you can then kind of share with other developers, and they're going to see it and understand what you're doing. So we did the first thing, right? So we have we're getting back our list of images, but now what we want to do is we want to loop through all of those images that we received, and we want to make a second call for each one of those images and download the binary data for that. So what he's setting up here is that images.map is going to go through every single one of those images, and it's going to return back the promise of the HTTP call for each one of those Ajax calls, right? So if he, as you see on line 20, when he prints out promises, that's not very useful. That's just, hey, here we're going to get back to you at some point, and we're going to let you know that these are all done. So if you could probably clear out line 20 now.
Yeah.
So now what we're doing is, out of that first anonymous function, we're going to return promise.all. So what promise.all does is it says when it's a promise itself, and it's a promise of all of the promises that are passed into it, and when they're all complete, then it's going to bubble out its then. So now we're able to do it. And go ahead and there it goes. Right. And you can do all of them just so that they can see like we have all. Taking a second. So what you're looking at here on the left, obviously, is text representation of JPEG. So it's not entirely that interesting. But but under the hood, what happened, right, is we went through, we made those 10 additional calls over to Flickr. We took the buffer array that we got back, and we just stringified it, and we're just showing it over there on the left. So it's really powerful, and whenever you get into working against APIs and stuff like that, this pattern comes up quite often.
Another thing that I've really found really cool lately is you can actually return the promise. So here we're returning promise. So if you have like a chain of things to do, kind of what I used to do essentially is you keep doing .then and then promise .then of some sort, and then you kind of get into your airplane mode here. But instead of doing that, if you have like an actual string of them, you could just return the promise and then start calling these .thens as they chain together. So we can do this and then.
The other great thing about doing it this way is that you only have to have one catch.
Yeah, and that's it.
Otherwise, you'll start to get airplane catches as well. This is something we've just discovered. I don't know, probably within the last 2 months or something like that, and we've really been able to go back and clean up a lot of our code.
Yep.
Cool. So I think, are we good to move to ES7?
Yeah.
All right, cool. So the last thing we're going to demo to you guys, and then we're going to open the floor for all of the questions that I'm sure that you have, is we want to show you the async await functionality that's coming in ES7. So again, we're running Node 7 in this demo, so we can actually use ES7, and we could use this in our code today. And we're actually have some projects where we're starting to bring this in. But in the browser, again, you'd have to use Babel to bring this functionality in, but it is starting to be supported because we now are into 2017. So by that very definition, we should start to be able to use the ES2017 features. I think you just showed the whole thing, right?
What's that?
Oh yeah, so we're not, like first show, okay, so show the promise, right? This is what we just did, right? So what we're going to do is we're going to rewrite this function using async await. So maybe clear that out so we can jump back and forth clearly. So just kind of familiarize your, remember this, imprint this on your brains, right? So now we're going to move over and we're going to walk through what this looks like in async await mode. So go ahead and jump back over. And are we executing this one now?
Yeah.
All right, cool. So what we're looking at here is that that line 5 didn't really change. That's still that get call that takes in a URL and just resolves it as a traditional promise. And but down below is where the actual coolness starts. So on line 14, you'll see that we enter into our function by giving it a little keyword of async in front of it. And that basically tells JavaScript everything inside of this scope I can do awaits and instead of having to do promise.then. So let's look at what happens on line 15. So line 15, is that word that you can hardly see is await, the thing that's pink right there. And we're awaiting get images for the URL. So if you'll remember in the previous implementation here, it was get images URL .then, and then we entered into a sub anonymous function that was underneath it right there. But if we come back over to 15, you'll see that it's more of an assignment, right? We say let images equal await get images. And what that's going to do is whatever get images resolves is going to pass right to that images variable. So it's super clean, right? And then on line 16, very similar. What we're doing is we're saying that promise.all again, and we're doing that almost that exact same function, image.map, get images. So we create an array of the promises to go get all of the images for each one of those. But again, we don't have a .then there. We're able to assign that right back over to that binaries function or that binaries variable, which we can then just print right out on line 19. So if you execute this,
it's going.
It's going, thinking about it. Or maybe it just doesn't work and we just made this whole thing up. All right, cool. So you can see tremendous a tremendous improvement in the readability of the code. And also just in terms of like how you get to write it, you don't have to worry about airplane mode. You know, some people would argue you're really just typing await in front of something instead of then after it, but I think that this really brings a lot of power. So with that, that's the end of our actual coding demo. So now I want to just open the floor up to anybody who has any questions or comments about what they just saw. A lot of hands. All right, come this way. What's up? Yeah, you put it in a try catch, and then whenever the promise rejects, then it will just trickle down into a catch block. And oh, I should probably repeat that. He asked, how does error handling work in async await. So it's a try-catch block. Anybody?
You on a mic?
You in the black? So what he's asking is, would line 17 execute before line 16? Is that what you're asking? Right. So that's actually the value, right? Or that's the magic, is that it's not doing what you would expect. It's not going on. The whole await actually pseudo stops execution at that point, and it won't move to line 17 until line 16 is done and has been resolved. So it's essentially the same as having that inner callback. You just don't have to airplane in.
So it kind of makes it asynchronous.
Yes. So the question is, or the statement is that it basically makes it into it takes asynchronous programming and it makes it look synchronous, and that's actually exactly what it's doing.
To the left.
I got a hand over here. I kind of need a runner to go back and forth on a microphone. Yes.
Use the spread, passing more or less objects or array to the function passing into it.
That's a great question. So the question is when you're using the spread operator, can you pass in more parameters than what the other side is expecting?
Or less.
Or less?
You can, as long as the spread is the last argument. So say for this instance, if we have our print volume, we can take other stuff here, and then print. Oops. All right, and then the other stuff, and if we pass in, and then I actually have to run it, so we set spread. And so essentially, yeah, it will take it, but the spread has to be the last argument.
Cool. Just looking for hands, comments, questions. Oh, over here. Good work, guys. I needed exercise this morning.
Seems like the kind of thing that we did with Dojo, particularly with the objects classes. Do you have any comment on what role Dojo plays?
Yeah, actually, so the question or the comment is that, hey, a lot of this stuff looks like what Dojo has been doing for many years. And it's a great observation. And the thing is that Dojo has been sort of on the cutting edge of solving a lot of these problems. On the board for ES6 and bringing a lot of these features to native JavaScript, they looked very closely at a lot of the stuff that Dojo was doing, as well as other languages, to try to bring in the best of breed from all of the different things. So Dojo has classes. Dojo has a lot of this, solving the problem of this and figuring out how to keep that scope around. And my opinion is it's great that we've had Dojo to give us all of this stuff. Whenever possible, though, it's always best to leverage the native language under the hood, and then just use the additional function and features that Dojo brings to the table, or any other library that you're choosing to bring in and leverage.
So do you find in your work then you're mixing those? In other words, you're doing as much as you can in native JavaScript, but you're still reaching into Dojo to do?
Yeah, actually, absolutely. And over time, what happens is you come back to your previous code and you see, hey, this used to need to be done this way, but now I have native pieces that I can just bring out of JavaScript, and I don't need to add this additional Dojo layer into it.
Thank you.
Yeah.
So how you compare with Microsoft TypeScript?
The question is, how does this compare with TypeScript? Well, so TypeScript, again, is just a transpiler that ultimately compiles down to ES5 or ES6 or whatever you set it to, and it's just a syntax that you choose to write in. Everything that you see here for ES6, one, you can write just native JavaScript in TypeScript if you choose to, But the thing is that the TypeScript is a very defined, very opinionated language from Microsoft, and it's really cool, and it adds a lot of cool functionality. Um, I find as a C# developer, if I hadn't spent as much time in JavaScript as I had, I would probably be doing most of my work in TypeScript. But I don't, because I actually understand JavaScript now kind of a lot better than I did when I was first transitioning as a C# developer. But TypeScript is very, very powerful, and it has a lot of good features in it. Classes being a big part of it, right? And proper object inheritance. I want to say TypeScript implements interfaces, which ES6 doesn't. So that's a nice, like, extra sort of a bit of syntax that you can get if you want to take that development model and stuff like that. So there's a lot of value in TypeScript. But the other thing is that TypeScript specifically, don't ever feel like you're 100% locked into the TypeScript world. If there's things that you that maybe work better with just native ES6 code, you can just throw that in there in line. Back there.
We have Async and Dojo declare.
Okay.
There's a lot of real stuff. I don't know if how you would do like the disinherited thing.
So the question is about Dojo's class declare statement, and that the Dojo has some additional object inheritance properties that we didn't demonstrate or aren't necessarily present in the ES6 class implementation. And the answer is yes. The ES6 class implementation is pretty bare bones at this point, and there are certain things, like I just mentioned, interfaces as well, don't exist in ES6. And Dojo has like some additional, because they've had the classes in the language for quite a while, and it's matured. So there's certainly more stuff in there, and if you find that you're leveraging that stuff in your code, then I would say keep using it in Dojo. Just know that if you're just simply setting up something that needs to have some getters and setters and some static properties and some exposed functions, ES6 gives that to you out of the box now, and you may not need to leverage that Dojo code.
Can you cancel a promise?
The question is, can you cancel a promise? And so it's an interesting question, because there was a very popular promise library from Kwazalski, I think is how you name it, named Q, which has been used in Angular and used in a couple other libraries, and it had a property that you could add to a promise of .timeout. So it's like, if this promise doesn't come back in a certain amount of time, go ahead and just reject the promise. The ES6 implementation of promise didn't bring that capability into it. So, but what they recommend is, if you do want to do a timeout, this inside of the promise that you want to have that kind of timeout, do a traditional set timeout, put the amount of time you want it to wait, and then just reject the promise. And how you would cancel a promise at any time is to execute reject. And the reject throws it out. But the thing is, you have to put some code inside of the promise to determine at what point you want that promise to be rejected. You can also have something, like if something's waiting on a promise.all or something like that, you could also put other code in there to kind of skip out of that if something else happens, right? Let's see, I think I had a hand right here.
Can you comment on any of the newer frameworks that are coming from background, like Rutherford?
Oh, sure. So the question is, can I comment on Backbone versus Aurelia? So the first answer is, I don't know what Aurelia is. So I'm certainly familiar with Backbone. I'm very familiar with Angular. Very familiar with Knockout.js. Vue.js is one that we've been doing a little bit of poking and prodding around with. And they're all cool. And the thing is that, Chad is a huge React fan. So he'll tell you all day long that React and Redux and Reflux is really like the way that the internet is going. So the framework works, right? We all have our opinions on, hey, everybody should do it using this framework because it's the best framework ever. It's a little out of the scope of this particular talk, because this talk is like, hey, here's native JavaScript and what it can do. I think that the more we understand what the underpinnings of JavaScript is capable of, the less reliant we become on some of these frameworks to give us some of these functionalities. Like for example, speaking to Angular and the watch capability, when I discovered proxies, I was like, wow, that really solves that problem in an elegant way. So much so that I might not need to use Angular watches anymore, right? Other hands? All right, I think obviously we'll be up here for the next 20 minutes or so while we transition to the next speaker. Please feel free to come up and ask any questions that you guys didn't ask, and I appreciate you guys spending the time with us.
Thanks.